If your ionic compound does not have a single element as its anion, its nonmetal part, it will have a polyatomic. Here's a list of some common polyatomics. If you notice, they are not single elements, they have friends. And they will not end in IDE as the single element anions do. They will end in either ATE or ITE, depending on which what the name of the polyatomic ion is. So a way to kind of remember that is this: if it has a T in the nonmetal or anion part of the formula, it's not going to be alone. It's going to have friends. Okay, so here's a guy with his arms outstretched, holding on to his friend's hands. So that's one way to remember that if it has a T in it, it is not a single element anion or nonmetal. It is going to be a polyatomic if it has a T in it. There are a couple of exceptions to that, and I'll go over those in a little bit. So let's jump into some examples here. If you are given Mg and then in parentheses ClO3, end parentheses with a 2 on the outside, the rules to naming this are pretty much the same with a couple of little tweaks. It's pretty much the same as with the single element anions. But I want to point out here that because there are 2 of the ClO3s, it needs to be in parentheses, because if there was not a parentheses here, then it would look like there were 32 oxygens in this formula, and there are not. There are there are 6 total, because there are 2 of these polyatomic ions with 3 oxygens in each one of them. All right, so to do this, we just follow the same rules. We write the name of the metal, magnesium, and then we write the name of the polyatomic. It's not going to end in IDE. That is just for single elements, with a couple of exceptions. So the name of this polyatomic is chlorate. So this is magnesium chlorate, and you can see on this list right here, chlorate's right there. All right, so let's try another example. Pretty easy. CaCO3. Okay, notice that this is not in parentheses because there is just one of these polyatomic ions. So we just name the metal, which is calcium, and the nonmetal, which is a polyatomic in this case because it's not alone. So it's carbonate. You can just look on your polyatomic sheet and see carbonates right here. All right, so let's do an example where we are given the name and then we have to come up with the formula. Beryllium phosphate. Okay, we can look on the periodic table and see that the symbol for beryllium is Be. Phosphate, we can look at the polyatomic list and see phosphate is right here. It's PO4, and notice that it has a -3 charge. Right, PO4, and it has a -3 charge. Beryllium has a +2 charge. And so then, just in the same way that we did with the single element anions, we just crisscross these. So this is going to be beryllium 3, and then in parentheses, phosphate with a 2 on the outside. Okay, so let's try a couple of examples with some transitional metals. All right, let's do FeNO3, 2. Okay, so NO3, we can look on the polyatomic ion sheet and we can see that NO3 nitrate has a -1 charge. -1. And since the iron, there's only